So what are you guys?
We're the Swartwood family.
So are you guys real Swartwood MCAT students?
Hell yeah!
Hi guys, so let's do a quick video on the Inscribed Angle Theorem. So, someone asked, are there different ways to prove this? How could you prove this? There are many different ways. I think one classic way is to do this. Let's say, let's take an inscribed angle, but not a random one, a special one. So let's pick one where one of the legs here basically is the diameter. Okay, so we'll pick this and that, and there's our chord. Okay, and so the inscribed angle here would be this guy. Let's call him alpha. Okay, so the question now is, how does this inscribed angle relate to the central angle? So you look at the chord that this guy's attached to, right? And you go from the center to the ends of that chord, and you get your central angle. Okay. And the question is, how are these guys related? So again, the main thing is it's all about the circle. It's all about properties of the circle. And you know, a big one is any point on the circle is equidistant from the center, right? So this guy's length, that guy's length, and that guy's length, they're all the same. Okay? Which means that if this guy is alpha, so is this guy. Okay? And so these two guys are, of course, the same angle as well. Let's call them beta. Okay? So alpha and beta, of course, don't have to be the same, but this guy's the same as this guy, and this guy's the same as that guy. Okay, no big deal. So now the thinking is, what can we do from here, right? Well, look big picture. Notice that we have one big-ass triangle, right? And in that triangle, you know the sum of the angles, so 2 alpha plus 2 beta, right? Alpha, alpha, beta, beta has got to add up to 180, okay? Which also means in general that alpha plus beta is equal to 90. That in itself is its own theorem, which is basically if you have the diameter and you pick any point in the circle and join the ends of the diameter to that point, that angle form will be 90. Okay, so that's its own theorem. So it turns out we have 2 beta, right? So look at this triangle right here. So you have 2 beta plus mysterious angle is also equal to 180. And you can clearly see if 2 beta plus 2 alpha is equal to 180 and 2 beta plus something is equal to 180, that something has got to be 2 alpha. You can also be formulaic. You can just solve for 2 alpha. So we can just do it. So 2 alpha is equal to 180 minus 2 beta, right? And that's clearly what you get here. Mysterious angle is equal to 180 minus 2 beta. So it's clear that this guy is the same as that guy. Okay, but you could have seen that already. Okay, all right, no big deal. So case 1 is done. So it turns out that if this inscribed angle is alpha, then the central angle corresponding to him is 2 alpha. Okay, so that's case number 1. And we're going to do what mathematicians love to do. Once we figure something out here, we're just going to milk it for all it's worth. Okay, so in the next case, instead of doing it from scratch, let's just try to get a setup where we end up in this case, which we already know. Okay, so what's case number 2? So yeah, not quite a circle, but pretend. Okay, so case number 2, we pick, again, some chord, some point, and this time we'll do this, and we'll have it so that each leg of this guy is not the diameter. Maybe the center is right there. Okay, so we're doing a case where the center is actually inside our triangle. Okay, we could do this proof from scratch, but let's take advantage of what we just proved, right? So again, the difficulty now is that we don't have a diameter, right? Or at least we don't have one of the legs being the diameter. So let's do it that way. Let's force that to happen. So let's connect the dots from here through the center and get ourselves a diameter. Okay. Now we can use what we know. So first, do you guys agree? If we have this set up over here, okay, for certain we know that this guy, since this guy has one leg which is a diameter, then you know if this angle is alpha, then you know the central angle corresponding to him is 2 alpha. Does everybody agree? Do you also agree that this guy, let's call him beta, since this guy has a leg that, well, one of its legs is a diameter, then the central angle corresponding to him is 2 beta. Does everybody agree? Okay, now let's go back to our original guy. Our original angle must be alpha plus beta, right? And the central angle corresponding to him must be 2 alpha plus 2 beta. Does everybody agree? So again, we see that whatever this angle is, let's call him smiley, right? That the central angle corresponding to him is double smiley. Okay? No big deal. So I mentioned there are 4 cases. This is case number 2. Let's do case number 3, okay? And again, we're going to do the same rule of thumb. Try to use what we already know. Wow, that's horrible, my bad. I can do a little bit better than that. Okay? And well, close enough. Okay, so we do it again, but this time let's place the center. So we did the case where one leg goes through the center, We did the case where the center sits inside the triangle. So now let's do the case where the center sits outside of the triangle. And here's our angle alpha again. Okay? Okay, so what I want to do is I want to make a statement about this guy right here. Okay? So this mysterious angle, what's it going to be? I mean, odds are it's probably going to be 2 alpha, right? But let's go through the motions anyway. Okay? So the logic should be that we can try to connect triangles up here and do stuff like that. That's totally fine. But if I were looking for a cheap way, and maybe the cheap way won't work, but we should give it a shot, I want to transform this problem with this problem into one that we've basically already done. So in order to do that, we need to take advantage of that center, right? So what we're going to do is basically create a diameter. So we do this again. Okay. Again, you know, I'm being super mellow, so I'll say create a diameter. You don't have to be super anal about is a diameter distance, is it a segment, blah, blah, blah. You know what I mean looking at the picture. Okay. All right. So we have this set up. Again, let's see if we have something we know. Well, if you look at this guy from here to here. In fact, let's make that yellow. Okay. That's the case we've already done, right? One leg is a diameter. So that means that this angle, this entire angle, the yellow angle, has got to be equal to what? Well, it's got to be 1/2 of the central angle, which will be this guy, corresponding to him. Does everybody agree? We need to give it a letter. Let's call it beta. So here's beta, and there's the central angle corresponding to him, and it's got to be 2 beta. So this is 2. Okay, and here's beta. Okay. Okay. But I need more. Because what we're going for is alpha in this mysterious angle that will hopefully be 2 alpha, right? Okay, but I still want to take advantage of the fact that I want to use an angle where one leg of it is a diameter. Okay, so obviously we took advantage of this. The original guy doesn't work, so why don't we take advantage of this guy here? So if we look at this angle, okay? So if we look at this guy, right? Then you can clearly see one of its legs is also a diameter, right? So now we can use the same property. Let's call this guy gamma. And then we know that the central angle corresponding to him is 2 gamma. Does everybody see that? So what I'm looking at here is this guy. That's my angle. And then the central angle corresponding to him is right there. Okay, so we have gamma and 2 gamma. Okay, and hopefully, running out of colors, huh? Hopefully this won't be that bad. What we really wanted, our target was this guy, the one that's doing this, right? Okay, so let's go back to that guy. So let's call him alpha. Okay, do you agree that if you take beta and you subtract gamma, you will get alpha? So we have beta minus gamma is alpha. Everybody agree? Do you also agree, looking at the central angle attached to him, if you take 2 beta minus 2 gamma, you will get this thing. Okay, and that is the mysterious angle we're looking for, right? Because again, I know it's kind of hard to see right now, but if I look for alpha, alpha is this. Right? The central angle attached to that chord is here, here. So it's this guy. Okay, but you can see that 2 beta minus 2 gamma is equal to the mysterious angle. Everybody agree? And you can clearly see that here's my alpha, beta minus gamma. Here's the mysterious angle, which is 2 beta minus 2 gamma. So it's twice as big. So again, we get that same fact, right? So if this angle here is alpha, the central angle corresponding to him is 2 alpha. Okay, so what's case number 4? So, you know, I don't know because it looks like we've done all the cases, right? Because we had the center on a leg, we had the center inside the triangle, and then the center outside the triangle. What else could you do? Well, there's one thing that we kind of assumed in the picture,